Hello, welcome to Sleepy Sage's Science Diary. I'm so glad you're here. Perhaps today has been exhausting for you, but sinking into deep reflection can be a way to relax. Either way, tonight's journey is meant for you. All you need to do is rest. Let your thoughts soften, let your breathing slow, and feel your body grow light as if gravity itself has eased. Tonight, we'll explore why the deeper we study the universe, the more despair we sometimes feel. Why does the deeper we study the universe, the more despair we feel? Imagine this: the cosmos emerging from nothing, an infinitely small point blossoming in utter silence into the vast universe we see today. But could this be nothing more than a carefully packaged story, crafted just so that human minds can comprehend it? The truth may be stranger than we dare to imagine. I hope the next few minutes bring you both wonder and comfort on this cosmic journey, and perhaps even a peaceful dream. Because when you look up at the night sky, those countless stars, galaxies, and clouds of cosmic dust you see make up less than 5% of the universe. The remaining 95% hides in the form of unseen and nearly undetectable dark matter, dark energy, and quantum fields permeating everything. Behind it all, is there a hidden pattern, a master code, a level of mathematical precision so perfect it feels designed? Or is it all just random chance? Science and philosophy force us to wrestle with both possibilities. On one side, the razor-sharp fine-tuning of physical constants, where even the slightest variation would collapse reality, seems to scream of design. On the other, physics suggests this might simply be a lucky roll of the dice in a vast multiverse, with infinite failed realities scattered across the cosmic landscape. Take gravity, for instance. If its strength were increased by even 1 part in 10 trillion, stars would burn too quickly, planets would never form, and life as we know it could never exist. This is the first paradox of the universe. Our existence hangs by a thread on exquisitely tuned constants. So, which explanation feels more reasonable to you, design or chance? But if the universe is designed, who or what is the designer? And if such a designer exists, who designed the designer? Inevitably, we spiral into an infinite regress, like cosmic nesting dolls. Perhaps this forces us to admit the limits of human understanding. Before the mysteries of the universe, we are like ants trying to grasp the architecture of a skyscraper. Even Einstein, often called the most brilliant mind of the modern age, admitted the failure of our existing theories when confronted with the structure of time. He believed space itself is a vast mental construct, bent and twisted by matter and energy. Near a black hole, time slows almost to a stop. At the speed of light, time ceases altogether. At the very first moment of the Big Bang, time as we know it may not have existed at all. Asking what happened before the Big Bang might be as meaningless as asking what lies north of the North Pole. Our trusted physical laws and everyday logic completely fail at the origin of the universe. If you could somehow reverse the river of time and journey back to that infinitely dense point, what would you see? The act of creation, or something utterly beyond our imagination? Some physicists suggest bold alternatives, like the cyclic universe hypothesis, where expansion and collapse repeat endlessly. But pause for a moment and consider yourself. Every atom in your body was forged billions of years ago in the fiery cores of dying stars. Quite literally, you are the universe made conscious. The cosmos looks back at itself through this strange phenomenon we call consciousness. Is this profound link between flesh and cosmos mere coincidence or evidence of something greater? dive further down into the quantum realm, and reality becomes even stranger. Quantum physics reveals that what we call empty space is never truly empty. Virtual particles flicker in and out of existence. Quantum fields surge and ripple beneath the calm surface of the vacuum. What appears still is actually a seething ocean of infinite possibilities. At the quantum level, the very idea of absolute nothingness dissolves. Yet, all our known physical laws break down at the singularity of the Big Bang. Our mathematics, our theories, none can describe it. It is the edge of human knowledge. So, is the imagined designer hidden in this unreachable frontier, behind the veil of our physics? Or does it simply mark the limits of our understanding? Either way, what lies beyond fills us with awe, mystery, and humility. And if we insist on invoking a creator, perhaps the most haunting truth is this: the questions about that creator may be even harder than the questions about the universe itself. But if a designer really fine-tuned the universe for life, then why does life appear so rare, almost absent across the vast cosmos we can observe? Most of the universe is hostile, even lethal, to the kind of life we know. And here on our lucky Earth, estimates suggest that over 99% of all species that ever existed are now extinct. Is this evidence for intelligent design, or evidence against it? Perhaps the problem lies in our narrow perspective. We are carbon-based organisms who evolved on a rocky planet orbiting a stable star, so our definitions of life and consciousness are deeply shaped by our own form of existence. But what if life can take forms we cannot yet imagine? What if consciousness could arise in the searing plasma of a star, or within the frozen gases of interstellar clouds? What if the universe itself possesses some diffuse form of awareness we cannot yet comprehend? At this frontier, the line between bold scientific speculation and philosophical inquiry begins to blur. Consider another great cosmic mystery: dark energy. This invisible force seems to be driving the accelerating expansion of the universe. Current estimates suggest it makes up about 68% of the cosmos, and yet we know almost nothing about what it truly is. Stranger still, its strength appears to be finely tuned, just enough to let galaxies form before the expansion tears matter apart. Another coincidence? Or a clue to the deeper nature of reality? Closely linked to dark energy is dark matter, which accounts for another 27% of the universe. Though invisible and undetectable directly, its gravitational influence acts like a cosmic scaffold. Without this invisible framework, galaxies would never have cohered, and stars themselves might never have formed from the primordial gas clouds. Add it up, and you realize all the ordinary matter, the atoms that make up stars, planets, oceans, and even you, constitutes less than 5% of the total universe. We, and everything we know, are the exception, not the rule. And yet, with a brain built from this tiny fraction of matter, humans have somehow developed the ability to probe the entire cosmos. A brain evolved to survive on Earth, to hunt, gather, avoid predators, has gone on to invent abstract thought, to grasp quantum mechanics and general relativity, theories that describe the most extreme states of reality. Our purely human mental constructs, mathematics, equations, abstractions, turn out to map with astonishing precision onto the fabric of the cosmos. Does this suggest that human thought is somehow aligned with an underlying logic of the universe? Or is it simply another coincidence that reality just happens to speak mathematics as its native language? Then there is the double-slit experiment, which shocked the world by showing that particles behave differently depending on whether they are observed. Reality itself seems to shift depending on whether or not we are looking. What does this mean about the relationship between consciousness and the physical world? Could the observer be, in some sense, a fundamental ingredient of reality itself? Physicists have proposed many interpretations. Some suggest that it is the act of conscious observation that collapses the wave function, making reality real. Others, like the many worlds interpretation, argue that every possible quantum outcome spawns its own universe, creating an endless, branching multiverse where all possibilities occur. Still others point to quantum entanglement, what Einstein called spooky action at a distance, in which two particles, no matter how far apart, remain mysteriously linked. Mathematically, many of these interpretations are consistent, but the pictures of reality they paint are nothing short of bizarre. If the multiverse theory is correct, then our universe is just one bubble in an infinite froth, each with its own constants, laws, and histories. In that case, the extraordinary fine-tuning we observe is not evidence of design at all, but a selection effect. We find ourselves in this particular universe simply because only in such a universe could observers like us exist. This is the anthropic principle, the idea that the universe looks just right for life, not because it was designed that way, but because in universes where it isn't, there is no one around to ask the question. At least for now, whether it be a lofty designer or the hidden realm of the multiverse, both remain far beyond the reach of our current experiments beyond proof or disproof. And yet here we are, tiny specks of dust forged over billions of years from the hearts of stars, daring to probe the depths of the cosmos with our crude instruments and limited minds. It is from this humble vantage point that we ask the ultimate questions about the universe itself and about the meaning of our own existence. Between the largest scales of the cosmos and the smallest scales of quantum reality, we glimpse a curious and mesmerizing symmetry. The vast cosmic web, stretching billions of light years, linking clusters of galaxies in filamentary structures, looks strikingly similar to the neural networks inside our brains. At the opposite extreme, at the Planck scale, some models of quantum foam echo the same complex web-like patterns. Are these similarities across unimaginable scales mere coincidences? Or do they hint at some deep fractal quality of reality itself, patterns repeating from the quantum to the cosmic? Some theoretical physicists go even further, suggesting that matter and energy may not be the true foundation of reality at all. Instead, information may be the most fundamental building block. The universe, in this view, is less a collection of particles and fields, and more a grand information processing system, a cosmic computation, or even a sublime simulation. If so, then the designer of our universe might resemble a brilliant programmer rather than a traditional creator deity. But the questions remain: who wrote the code? What kind of unimaginable hardware does it run on? Once again, we find ourselves caught in the infinite regress of the cosmic nesting doll. And maybe you're wondering, are we simply overthinking? Are we projecting human concepts of design and purpose shaped by our own lives onto a universe that may lie utterly beyond them? Perhaps reality just is simple, raw, without intention, without hidden meaning. Our restless questions may be nothing more than the unavoidable byproducts of a curious brain facing an overwhelming unknown. Yet, just as we try to resolve the universe into something simple, the cosmos throws us into another paradox, this time in the world of entropy. The second law of thermodynamics tells us that in any closed system, disorder inevitably increases. If the universe itself is such a system, it must evolve from order to disorder, marching toward a heat death. And yet here we are, life, highly ordered, impossibly complex, defying entropy's tide. Life thrives by exploiting energy flows on Earth, solar energy to maintain its structures. But this local decrease in entropy always comes at the cost of a greater increase in the larger system, which leads to the haunting question: what provided the universe with its original low-entropy state? Why did the cosmos begin in such an extraordinarily ordered condition, so improbable as to seem impossible? Some propose that this puzzle points toward a cyclic universe, a cosmos that expands, contracts, and is reborn, with black holes playing a role in resetting entropy. Others suggest our observable universe is just a rare low-entropy patch within a larger multiverse. And still others argue that time itself, the arrow pointing from past to future, is nothing but a macroscopic reflection of entropy's increase. In a hypothetical region of decreasing entropy, time might even appear to run backward, which brings us to an even more unsettling thought experiment: the Boltzmann brain paradox. If the universe is infinite in time and space, then, according to statistical mechanics and quantum fluctuations, it is far more likely for a random fluctuation to assemble a single brain, complete with false memories and the illusion of consciousness, than it is to produce an entire ordered universe with billions of years of evolution. Such a Boltzmann brain might exist for only a fleeting moment, yet its subjective experience could feel identical to yours right now. From a purely statistical perspective, the probability of a brain like this arising is far higher than the probability of a universe like ours evolving. Does this mean that, compared to being a real individual in a real universe, you are more likely just a fleeting Boltzmann brain, experiencing an illusory reality? Cold, merciless mathematics seems to lean toward this unsettling conclusion, and that is precisely why physicists regard it as a profound paradox yet to be resolved. What's especially striking is how our universe behaves so differently at different scales. On the macroscopic level, everything appears to follow deterministic physical laws. Given precise initial conditions and enough computational power, we can predict the future state of a system with astonishing accuracy. Yet, when we dive into the quantum realm, determinism dissolves into fundamental probability. We can never predict with certainty where an electron will appear next, only its likelihood. Some philosophers and theologians see in this quantum indeterminacy a doorway to free will, a mechanism that might subtly influence and shape reality without breaking the known laws of physics. But is this randomness truly the universe's core nature, a deeper layer of determinism in disguise, or could it really be a source of freedom itself? And if quantum uncertainty already shakes our understanding, the concept of infinity pushes it to the edge. Certain cosmological models suggest the universe may be infinite, extending endlessly beyond what we can observe. If space is infinite, probability demands a dizzying conclusion. Any finite configuration of matter with a non-zero chance of existing must repeat infinitely. That means somewhere, in the vastness of the cosmos, there must be another Earth, almost identical to ours, with another version of you, carrying the same memories, perhaps even pondering these very same questions right now. This is not wild science fiction, but a logical consequence of infinite space and finite arrangements of matter. So, does such cosmic repetition make your existence more meaningful or strip away your uniqueness, reducing you to one pattern endlessly replayed? Are you truly the one and only you, or just one instance of an infinite template? Even if space is finite, time itself may be infinite, stretching endlessly into the future or cycling through eternal cosmic rebirths. And if the many worlds interpretation of quantum mechanics is true, reality branches at every quantum event, spawning an incomprehensible multiverse where all possibilities unfold. Infinity upon infinity, layered without end, an intellectual labyrinth that our finite minds can scarcely begin to grasp. So is infinity a genuine key to the universe's deepest reality, or just a mathematical abstraction, something our theories invoke when they reach their breaking point? At this stage you might ask, what does all this grand speculation about the cosmos have to do with me? The answer lies closer than you think. Every atom in your body, without exception, was forged in the fiery hearts of ancient stars billions of years ago. The iron in your blood, the calcium in your bones, they are stardust. In the most literal sense, you are not separate from the universe. You are the universe condensed, conscious, reflecting upon itself. Whether this is the product of design or of chance, the fact that you exist here and now, capable of asking these questions, is itself a miracle worth marveling at. And yet, the most fundamental mysteries of the cosmos remain unresolved. Why is there something rather than nothing? Why do the constants of nature take the precise values they do? Is our universe unique, or one among countless others in a vast multiverse? Did it have a definite beginning, or is it eternal? And what about consciousness? Is it merely an emergent property of complex matter, or is it woven into the very fabric of reality? Does the universe have a purpose, or does it simply exist, indifferent, without design or intention? These unanswered questions may one day find resolution through science, or they may mark the outer limits of human understanding itself. Some cosmic mysteries may remain forever beyond our reach. Even the very question we have been asking, who designed the universe, might itself be fundamentally flawed. Perhaps the way the question is framed already smuggles in anthropocentric assumptions that do not apply to ultimate reality. We humans are accustomed to thinking in terms of causes and effects, beginnings and endings, intentions and purposes. But the principles governing the universe at its deepest level may transcend all of these categories, which arise from our limited macroscopic experience. Consider quantum entanglement. Two particles, no matter how far apart, influencing each other instantaneously, defying our classical sense of local causality, or general relativity, merging space and time into a dynamic four-dimensional space-time, overturning our intuitive notions of before and after. If closed time-like curves are theoretically possible, then even the very concept of a first cause collapses. So perhaps the universe is not designed by some external intelligence after all, but is instead a spontaneous, emergent phenomenon, like frost patterns forming on a winter window, delicate and intricate, yet arising naturally from simple physical rules. The cosmos may be crystallized out of quantum possibilities and fundamental interactions, or even born through a cosmic bootstrap paradox, self-creating, self-sustaining, generating its own initial conditions in a causal loop beyond linear time. Another possibility is that universes themselves undergo something like natural selection. Among countless cosmic seeds, only those with physical constants favorable to complexity and life survive and evolve. And yes, we cannot rule out another scenario. Perhaps there is a designer, but not the anthropomorphic deity of tradition, rather, a higher dimensional intelligence or principle, operating at levels we cannot yet comprehend. If such an intelligence exists, then how do we reconcile it with the Drake equation and the paradox of the Great Silence? The Drake equation suggests there should be thousands, even millions, of intelligent civilizations in our galaxy, and yet the cosmos remains silent. Does this silence mean that civilizations inevitably self-destruct? That barriers to interstellar communication are insurmountable? Or are we truly alone? And what if the silence is deliberate, that advanced civilizations have chosen to hide themselves? If humanity is the only intelligent species in the observable universe, what does that mean for design? Should a carefully designed cosmos not be filled with life and intelligence? Or is a single reflective species, one capable of contemplating the universe, already the ultimate goal of such a design? Paradoxically, whether alien intelligence exists or not, neither answer resolves the question of design. Each simply reframes the ancient riddle from a new perspective. Now, let us venture one step further. Suppose advanced civilizations do exist. They may already have transcended biology itself, moving into a post-biological stage. Their forms of existence, their modes of communication, could be utterly unlike anything we imagine. They may have uploaded their minds into artificial substrates, or evolved into beings of pure energy, dwelling within stars, or even at the edges of black holes. Their sense of time and scale might be so alien that our few decades of radio astronomy are laughably inadequate to detect them. The darkness of the universe may hide intelligences so advanced that they elude our very categories of thought. And perhaps intelligence is not confined to civilizations at all. Perhaps the universe itself is a form of mind or consciousness. An ancient philosophical view, panpsychism, has seen a revival in recent years. It suggests that consciousness is not just the product of complex brains, but a fundamental and universal property, intrinsic to matter itself. Modern theories like integrated information theory, (T), take a similar angle, framing consciousness as a function of how effectively a system integrates information. By this logic, consciousness is not limited to human brains. It could emerge in many natural systems or even in the universe as a whole. If so, could the cosmos itself be an unimaginably vast integrated mind, and our individual awareness merely tiny nodes within it? These ideas may sound wild, even fantastical, but they are raised seriously for a reason. They highlight the most fundamental, the most perplexing mystery at the core of our existence: consciousness itself. This subjective world we each experience directly still cannot be fully explained by even our most advanced physical theories. How does the objective material brain give rise to the first-person experience of consciousness? Philosophers call this the hard problem of consciousness. It may not only be the key to understanding the brain, it may be the key to understanding reality itself. If consciousness is a fundamental property of the universe, rather than a lucky accident emerging from complex matter, then our cosmos is not a cold, soulless machine. It would instead resemble a living expression of mind, a vast, animated intelligence woven into its very structure. At this boundary, science and philosophy blur. Some physicists, starting from the nature of time, suggest that our sense of temporal flow may itself be an illusion. In the so-called block universe model, the past, present, and future all coexist equally within a static four-dimensional space-time. Your birth, your life experiences, your death, even this very moment of listening, all are just fixed points in an eternal block. Nothing happens in the traditional sense. Everything simply is. This highly deterministic vision seems, in one sense, to support the design hypothesis, like a cosmic epic with every scene and ending already written. But it also raises unsettling questions. Do we truly have free will? Does our life carry meaning if the story is already complete? In sharp contrast, Other physicists argue that the future remains open, not fully determined, but co-created through the choices and actions of conscious beings. John Wheeler's participatory anthropic principle offers a striking example. He proposed that observers, especially conscious ones, are not passive spectators but essential participants. Reality itself crystallizes out of quantum potentialities only through observation. In Wheeler's words, the universe gives rise to consciousness, but consciousness gives meaning to the universe. This perspective offers a middle ground between pure design and pure chance. The universe's evolution may be shaped partly by physical necessity, partly by unpredictable quantum randomness, and partly by the active participation of conscious beings. But then we encounter phenomena that destabilize our sense of reality, such as the Mandela effect, where large groups of people vividly remember events or details that never occurred. Are these simply collective memory errors? Or do they hint at something stranger? Could consciousness, in rare cases, slip across similar parallel universes, carrying fragments of memory from one reality into another? Or is reality itself more fluid than we assume, malleable, responsive in some subtle way to our states of awareness? Mainstream science favors fallible memory as the explanation. But even so, such anomalies remind us that the reality we experience may be far more constructed by the mind than we like to admit. And then comes an even more radical possibility: the simulation hypothesis. What if our entire universe, including ourselves, is nothing more than an unimaginably complex computer program? If a civilization reaches a sufficiently advanced level, they would almost inevitably have the ability to create simulations indistinguishable from reality. Not just one simulation, but potentially billions of them. Statistically, it may be far more likely that we live inside a simulation than in the one true base reality. If that is the case, then the designer is simply the programmer who coded this universe. But that only pushes the question back one step. Who designed them? On what substrate does their own reality run? Once again, we find ourselves trapped in an infinite regress, the cosmic nesting doll of origins. Perhaps, in the end, all these questions converge on the deepest riddle of all. Why is there something rather than nothing? The subjective world we each experience directly still cannot be explained by even our most advanced physical theories. How does an objective physical brain give rise to the first-person perspective of consciousness? Philosophers call this the hard problem of consciousness. It may not only be the key to understanding the brain, but also the key to understanding reality itself. If consciousness is a fundamental property of the universe, rather than a lucky accident emerging from complex matter, then the cosmos is not a cold, soulless machine. Instead, it would be a living expression of mind, perhaps even a grand intelligence in its own right. Here, the boundary between science and philosophy begins to blur. Some physicists suggest that our sense of time's flow may itself be an illusion. In the block universe model, the past, present, and future all coexist within a static four-dimensional space-time. Your birth, your entire life, your death, even this very moment, are simply fixed points. In this picture, nothing truly happens. Everything simply is. This deterministic model seems, in one sense, to support the idea of design like a cosmic story already written from beginning to end. But it also raises troubling questions. Do we really have free will? If the story is already complete, what becomes of meaning? Others argue the opposite, that the future remains open, co-created by conscious beings through their choices and actions. John Wheeler's participatory anthropic principle embodies this idea. Observers are not passive, but essential. The universe gives rise to consciousness, but consciousness, in turn, gives the universe meaning. This view suggests reality is shaped by three forces: physical necessity, quantum randomness, and the active participation of conscious life. But then, we encounter strange phenomena that challenge our trust in reality, like the Mandela effect, where large groups vividly recall events that never happened. Are these just memory errors, or hints of something stranger? Could consciousness, in rare cases, cross between nearly identical parallel universes, carrying fragments of memory? Or is reality itself more fluid and responsive to our awareness than we think? Mainstream science favors fallible memory, but even so, such anomalies remind us that our reality may be far more constructed by the mind than we assume. And then there's the most radical idea of all, the simulation hypothesis. What if our universe is just an extraordinarily complex computer program? If advanced civilizations can create countless realistic simulations, then statistically, we're more likely living in one of those than in base reality itself. If so, the designer is simply a programmer. But that only shifts the question back: who designed them? What hardware runs their world? Once again, we face the infinite regress of the cosmic nesting doll. Perhaps all of these questions ultimately converge on one riddle: why is there something rather than nothing?